Factoring difference of squares problems. Difference of squares problems. Difference of squares always have two terms. They are always minus, and they must have perfect squares so that we can get the square root. They are in the form a squared minus b squared, and will factor in the following manner using the square roots. So we'll have one parenthesis with plus and one with minus, and we'll have the square roots of each factor inside. Let's look at an example. We're going to factor x squared minus 49. First of all, it is two terms. It's minus. If we can get square roots, we can do it with this technique. And we can for x squared, the square root would be x. For 49, the square root is 7. So it will factor into two sets of parentheses and different signs so that they can multiply to give a negative. And then we use the square root. So for x squared, we will have x and x. And for 49, we will have 7 and 7. Your check would be a FOIL because we have two binomials. So if we do the check, we would have our first terms, x times x, x squared, outside minus 7x, inside plus 7x, and minus 49 on the last terms. Your outside and inside terms are going to cancel out, and so that will give you just x squared minus 49. Let's try another problem. X squared minus 64. It is two terms, it's minus, and these look like perfect squares. So we should be able to factor it with this technique. So we'll do our parentheses, different signs, and the square roots. And this is such a nice pattern that I don't even bother to check. Let's try another example. Factor 4x squared minus 1. So it is two terms, it's minus, and it looks like perfect squares. So we'll do our parentheses, different signs. The only extra piece is we have a number and a variable this time to do the square root of. But for 4, we can do 2. For x squared, we can do x. And then the square root of 1 is 1. So it's going to work. Our next example seems to be turned around backwards, but we can still work it, and we'll just leave it in this order. So it is two terms, it's minus, and these are perfect squares. So we'll do our parentheses, different signs. For 16, the square root is 4. And for y squared, the square root is y. You do need to have the y's at the end, so you'll have minus y squared. If you put it at the beginning, you would end up with minus 16. So the order is going to matter there. For our next example, it is two terms and it's minus, but the problem is our 3 is not a perfect square, so we're not going to be able to do squares right away. However, we could do something old. We could take out a greatest common factor. So we'll do that first. So a 3 is a common factor. We'll do a GCF. Remember, when you do GCF, it's one set of parentheses. And we'll put the missing pieces. So we're missing an x squared. And to get back the 12, a minus 4. Now, because our exponent is still to the second power in the parentheses, we have to see if this piece will do more. Our 3 is finished. We're going to just bring it down. But this parentheses is actually a difference of squares now. So we need to continue to factor it. And different signs. X and x, and the square root of 4 is 2. So we need all 3 of these pieces for our answer. Let's look at this problem. It is two terms, and it looks like squares. The trouble is it has a plus instead of a minus. Let's see what would happen if we tried to factor it. So we could do our x's. And to have a positive here, you're going to have like signs. So either 2 pluses or 2 minuses. So if we did 2 pluses, and you're going to multiply to get 9. So if we tried 3 and 3, when we do a check, we pick up an extra term that's not in the problem. So we get a 3x plus 3x is a 6x, which is not in our problem. If we had done a minus sign in each one, we would have just a minus 6x. So you're going to get an extra piece. The only way to make that middle cancel out is if you have different signs, a positive and a negative. But to have different signs, this must be a minus. So we've tried these things, but they're not going to work. So this one is prime. It's not going to factor, so we will just say it is prime. And the plus is the clue. Let's look at this example. It is 2 terms and it's minus. The thing that's different in this problem is our exponent is a 4. We might be able to make a 4 work if we could take a square root. So you might just guess on the side, and a reasonable guess for the square root of x to the 4th is x squared. So if we tried it times itself, and that does give x to the 4th. So x squared is the square root of x to the 4th. So we do have a difference of squares here. And our square roots will be x squared. Now, because you are still to the second power, you have to see if these will do more. The first one will not do more because it is a plus. So with a plus, it's not going to do more. So this one is just going to come down. It's finished. The second one, though, is a difference of squares. So we're going to go from x squared down a level lower to x to the 1st, plus and minus 1 and 1. And so this last line is our answer.